In this world, all items carry their units. For example, in Singapore, the units of money is in dollars and cents. But in this topic, we focus on the measurement, which is based on the international system of units. Then we explain what is uncertainty, follow with the classifications of uncertainties, or we call types of uncertainty, how to determine the uncertainties by using the equations and graphs. Lastly, we try to define how to minimize uncertainties. In the measurement, we have identified the smallest quantity, so we call them base units. The base unit is the fundamental unit which is independent and cannot be derived from other units. There are 7 base units: length in meter, mass in kilogram, time in second, electric current in ampere, temperature in Kelvin, amount of substance in mole, luminosity of intensity or light density in candela. Whereas the derived unit is the combinations of other base units. For example, units of velocity, which consists of meters and seconds. Some of the units are scalar or vectors. What is called scalar quantity? Scalar quantity is one which has magnitudes but no direction. For example, time. It does not change with location. A vector is a quantity which has direction as well as its magnitudes. For example, force. When you apply force in different directions, the strength of force varies. We have 2 types of error. One is called systematic error and another one is called random error. What is systematic error? The error created by the system or equipment are usually differ from the true values, or we call exact values. It can be overestimated or underestimated. For the random error, from the word random, it means the errors are scattered around its true values. Since the uncertainty or errors have fixed patterns or random patterns, so how do we classify them? Are they precise or are they accurate? It is very easy to confuse with precision and accuracy. Precision is to analyze the spread from its true values, whereas for the accuracy is to see how closest to its actual value. There are 4 experimental results shown on 4 graphs. So, how to determine the type of uncertainty? Graph 1. The true value is 9.5. All the experimental results are far away from the true values. The result spreading is not very wide. So, we conclude this set of experimental data is precise but not accurate. Look at graph 2. The data collected are all close to 9.5, with the spread is narrow, so we said it is accurate and precise. Graph 3. The mean value is 4 near to 9.5, so it is accurate, but due to its spread is wide, therefore we say that it's not precise. Graph 4. The mean value is away from the true value, so it is not accurate, but due to its spread is wide, so it is not precise. The smaller units for the measurement tapes can be up to millimeters, whereas for micrometers, it can be measured to the smaller unit of micrometers. So how do we determine the uncertainty on the scale? The rule is the uncertainty is determined half of the smaller division. Look at this example. The smaller unit of one division is 0.1. Hence, the uncertainty should be 0.1 divided by 2 equal to 0.05. On the right hand side, the smaller unit is 0.01. Hence, the uncertainty is equal to 0.005. When we use the reading machine, we will adjust the scale to 0, but not all the machine can do it. So when there is no item placed on the measurement tool, the reading should be 0, but the scale on the tool shows a value of reading. This value we call zero error. From the words direct interpret, 0 it means no item but it has error. In figures 1, A is the variable which has the 0 all aligned. It means that 0 error equals 0. B, there is a positive 0 of 0.03 cm. It means that the bottom scale with the 0 moves on the right of the main scale. C, negative 0 error of minus 0.06 cm, which has the bottom scale moved to the left of the main scale. So now look at the examples in figure 2. We have the main scale. It shows the reading is 3.34 millimeters. In this measurement tool, it has the negative 0 error of 0.04 millimeters. So our final answer must have the reading minus away the negative 0 error. In measurement, we may use ruler to measure length, stopwatch to determine time. When there are more than one instrument to be used, how do we determine the uncertainty of the final reading? Look at the first uncertainty of extraction and subtractions. For example, C equal to A plus B or C equal to A minus B. Both of them, the uncertainty is equal to delta C equal to delta A plus B. For example, we use two rulers to measure a length of the bar. Ruler A measures the total length and the ruler B measures the first sections of the bar. Remaining sections can be determined by C equal to A minus B. As the measurement shows, A equal to 300 plus and minus 0.5 cm, B is equal to 105 plus and minus 0.4 cm. The remainder section of the length C should be equal to the both difference of the A and B length. It means is 300 minus 105. Uncertainty is 0.5 plus 0.4. Remember, it is not 0.5 minus 0.4. Second uncertainty equation is for multiplication and division. E equal to A times B or E equal to A divided by B. Both of them share the same uncertainty equation. The uncertainty is a ratio sum. For example, delta E divided by E equal to delta A divided by A plus delta B divided by B. Let us see a simple example. Velocity equal to distance divided by time. If the measured distance is equal to 5.3 plus and minus 0.5 meters and time equal to 7 plus and minus 0.45 seconds, so the velocity of the fraction should be equal to delta V divided by V, and the result is shown as 0.05 divided by 5.3 plus 0.45 divided by 7. From above, delta V can be found. Then we will be able to write down the velocity values plus its uncertainty. The third uncertainty equations for quotient, for example, A equal to B power of 3, which is equal to B times B times B. Based on the last equation, delta A divided by A should be equal to 3 times of the ratio of delta B to B. Hence, the quotient equation of A equal to B power of n should be equal to delta A divided by A equal to n times of delta B divided by B. Subsequently, we see A equal to B power of n times C power m. The ratio of delta A divided by A is equal to n times of delta B divided by B plus n times of delta C divided by C. This is a more challenging question. In the expression of Q, it consists of a term of subtraction. We have to choose alternate way by letting P equal to P1 minus P2. I believe the subsequent steps you should have no problem to digest and understand. This is a revision question. In the question, it given to you currents as well as resistor. In the resistor, The uncertainty is in terms of percentage, so you have to convert the 2% of percentage in terms of values. I leave this question for you to read. We have done quite a lot of examples in uncertainty. What causes uncertainty? There are only two reasons. Uncertainty caused by system or uncertainty caused by human or environmental changes. So if the uncertainty is caused by the system, the error usually is very systematic. How to minimize it? It's only two ways. One is by calibration. Second method is to read the zero error. If let's say the uncertainty is caused by the human or environmental changes, then it is very difficult to predict because it's the experiment and take the average value.